Hello, my little French fries. How are you today? Hopefully you're having a good day. I'm having a good day. Today we're going to get to talk about greatest common factor. So the other day we were talking about prime factorization, and we were talking about how to find the factors of a number to help us reach the prime factorization. And we used a factor tree to help us do that. And today we're going to continue on working with factors, and we'll actually get to use our factor tree for something different other than just to find prime factorization. We're going to find out why finding prime factorization is helpful. So our lesson is on greatest common factor today. And so we have an objective that we need to meet. And our objective is we will be able to find the greatest common factor of two numbers less than 100, okay? And then our essential question, the question that we should be thinking about, is how do you find and use the greatest common factor of two numbers, all right? So that's our goals, and we're going to start by making sure we have our notebooks out so that we can take notes. All right, and at the top of our note page, we're going to write greatest common factor. And remember, if I'm writing it, that means you are writing it. So greatest common factor. You can underline it if you want. Okay, that's our header. I'm going to auto focus it a little bit more for us. Okay. All right, so as usual, I like to always talk about some vocabulary first so that when I'm saying things, you will have a better understanding of what I'm talking about. So our first vocabulary term is going to be a common factor or common factors. So common factors are factors that are shared by two or more numbers. All right, and then the next definition we want to look at is the greatest common factor. Okay, and the greatest common factor is also called the GCF if we're just saying it really nice and quick. So you'll get used to hearing GCF. The GCF is the greatest of the common factors between two or more numbers. Okay, so that's our vocabulary for the day. Okay, so when we're talking about the greatest common factor, we're talking about if we find all of the factors for a number, then we can go ahead and look at the factors for this number, and then look at the factors for this number, and whichever factors they share we're going to look for the highest value factor that they share. Okay, so greatest means highest value. Okay, all right, so let's start with, first, we'll do old school. Let's start with an example. And we're going to find the GCF, told you we were going to use that a lot, of 24 and 40. Okay, so we're finding the GCF of 24 and 40. Okay, so the first thing that I can do, the first way that I can find them is by listing the factors. Okay, so let's list the factors. Okay, so I said 24 and 40, so the first number is going to be 24. And what is the first set of factors that goes into 24? Remember the other day when we were talking about prime factorization, I said start with the lowest number, right? So the first would be 1, right? 1 is a factor of 24. And 1 times 24 equals 24. Okay, now I go to the next number. I'm going to go in order. 2. Does 2 go into 24? It's an even number. It sure does. So, oops, sorry. 2 times 12 equals 24. All right, next one. 3. Does 3 go into 24? It sure does. 3 times 8 equals 24. Okay, next number is 4. 4 goes into 24, hopefully you said 6 times. Okay, and then next we would go to 5. 5 doesn't go into 24, right? It can go into 20, it can go into 25, but not 24. So then I look over here and I get to the 6 and I'm done. Okay, so when my bottom number on this side is the next number, I'm done. Okay, so I've listed all my factors for 24. Let's do 40. Okay, listing the factors for 40. First of all, 1. 1 is a factor of every number, right? So 1 times 40. Next, 2. 2 goes into 40. Yep. 20 times. 3. Does 3 go into 40? 3 times 10 is 30. 3 times 12 is 36. 3 times 15 is 45. Now, it doesn't go in. Oops, sorry. I don't know why I wrote it. I said it doesn't go in. Silly girl. Okay, so I know 4 goes into 40, though, doesn't it? Because that's an obvious one. 4 goes into 40 how many times? 10. Okay, let's try 5. Does 5 go into 40? Yep. 5 times 8. Okay, 7. Does 7 go into 40? 7 times 6 is 42. 7 times 7 is 49. Nope, doesn't go in. And we know when we get to 8, not working, okay? So I've listed all the factors. The next thing I would do is when I list the factors, I go like this. 24 gives me 1, 2, 3, 4, and then go from the bottom. 6, 8, 12, 24. Okay, now I'm going to list 40. 1, 2, 3. Silly, I did the 3 again. 1, 2, 4. 5, 8, 10, 20, 40. Okay, so now I'm going to look for my common factors, the factors that are the same between the two numbers. Well, I say I've got 1, I've got 2. I don't have the 3. I have 4. Those are the same. I don't have a 5. I don't have a 6. Oh, I have an 8 the same. I don't have a 10. I don't have a 12. I don't have a 20. I don't have a 24. And I don't have a 40. So, okay guys, what's my greatest common factor? Hopefully, you said that my greatest common factor is 8. Okay, but we're not done. That's not it. Now I'm going to show you how do we use prime factorization to find our greatest common factor, okay? So for prime factorization, we're going to find the prime factorization for both numbers, okay? So first, we're going to do 24. Okay? Well, remember when we do prime factorization, we're just looking for a pair of factors, right? But I like to use the smallest prime number that goes into both. So I'm going to pick that goes into the number. So the smallest prime number is 2, right? Because remember, 2, 3, 5, 7, 9, 11, 13, 17, 19. Okay. All right. So 2 goes into 24 12 times. I know that my 2 is prime, so I'm going to circle it because I'm done with that branch, remember? Okay, now I'm going to do the 12 part. Well, 2 goes into 12. How many times? 6. 2 is prime. I circle it. 6. Well, 2 goes into 6. 3 times. And now I have a prime 2 and a prime 3. And when I have all prime numbers at the bottom, I'm done, right? So my prime factorization for 24 is 2 times 2 times 2 times 3. All right, now I'm going to do 40. All right, 40. Again, just like I did before, I'm going to choose my lowest prime number that goes into 40. Just because it's the easiest way, I get to kill a branch right off the bat. I love that. Okay, so 2 goes into 40 20 times. Well, now I have to do a new branch for 20, right? 2 is a prime number and it goes into 20. So I'll put that on the left, and it goes into 20 10 times. Okay, so my factor 10, I still can keep going, right? 2, prime number, it's a factor of 10. And 2 goes into 10 5 times. So 5 is also a factor, and 5 is also prime. So I'm done. Okay, so for 40, my prime factorization is 2 times 2 times 2 times 5. Okay, so I've done the prime factorization, but it still didn't tell me what's the greatest factor yet, right? I have to do a little bit more work, all right? So just like when we compared factors here, we're going to compare prime numbers down here, okay? So we're going to compare the prime factors down at the bottom, okay? So if you look, I have a 2 and a 2. That's the same. And if you look, I have another 2 and another 2. That's the same, so I circle it. And if you look here, I've got another 2 and another 2. So I circle those. Now my last factor here is a 3, and my last factor here is a 5, my last prime factor. So I don't use those ones because they're different, right? They're not the same. Okay, so my GCF is 2 times 2 times 2. And another way of saying that is 2 times 2 is 4, times 2 is 8. Okay? And don't forget, you could have also written this as 2 to what power? Hopefully, if you're thinking, you came up with cubed. 2 cubed. 2 to the 3rd power. Okay? So, you see we did it here, and we listed out the factors, and we came up with 8. And we did it here, and we used prime factorization, and we also came up with 8. So, both methods are correct. Now, sometimes it's easier to use listing factors, and sometimes it's easier to use finding the prime factorization. So now we're going to practice a few using the different methods. Okay, so for these ones, I want you to list the factors. Okay, to find the GCF, greatest common factor. Okay, so for number 1, we're going to do 8 and 36. For number 2, we're going to do 18 and 72. And for number 3, we're going to do 14, 28, and 49. Okay? So go ahead and pause this video and work at solving those 3 by yourself using the listing factors method. Okay? And then when you unpause the video, when you come back to me, you're going to go over it with me and we're going to see if you came up with the same answers, okay? Okay, so hopefully you have paused it and now you're back because you've got your answers. And let's see what we've got. Okay, let's list the factors for 8. For 8, I'm going to put this a little bit bigger just so you can see because I'm going to write smaller here, okay? For 8, I have, sorry, no prime factorization here. I'm just listing. Okay, 1 times 8, I have 2 times 4, 3 doesn't go into it, and at the bottom I'm right back to 4. So those are my factors, okay? For 36, I have 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. Okay, and I got to 6 on the other side, right? So I have 6 here and 6 here, so I know I'm done. Okay, so now when I look at my factors, I'm going to list them. I can list them on top of each other. 8 is going to be 1, 2, 4, and 8. And then 36 is going to be 1, 2, 3, 4, 6. Don't write 6 again. 9, 12, 18, and 36. Okay? And this one's pretty easy to find my duplicates, right? So I've got 1 is the same, I've got 2 is the same, 3 is not the same, I've got 4, and 8 doesn't copy. So my GCF is 4. Okay, number 2. 18, listing factors. So 18 listing factors, I've got 1 times 18, 2 times 9, 3 times 6, 4 doesn't work, 5 doesn't work, and I'm right back at 6. So I'm done on the 18. Okay, 72. I've got 1 times 72, 2 times 36, 3 times 24. Does 4 go into 72? 4, 32. 4 times 18. 5, does 5 go into 72? Well, I can see it doesn't end with a 0 or a 5, so I can say nope. 6 goes into 72 12 times. 7 doesn't go into 72. 8, does 8 go into 72? 8 times 9. And I'm right down at the bottom, aren't I? Okay. So now I kind of ran out of room a little bit, but because my lists are kind of short, I can kind of look at my list now, can I, and see what is my greatest common factor. Okay, so I'm going to use a different colored pen just so we could see it better because I'm leaving them in the list and I ran out of room, okay? Okay, well, I definitely have a 1. I definitely have a 2. I have 3. I do not have a 4. I do have a 6. I do not have an 8. I have a 9. And I don't have a 12, but I do have an 18. So what is my GCF? My GCF is 18. And that's okay that your GCF is one of your numbers. Okay? Okay, last one. Ready? 14. I have 1 times 14. 2 times 7. 3. Nope. 4. Nope. 5. Nope. 6. Nope. I'm done. Okay. 28. 1 times 28. 2 times 14. Does 3 go into 28? 9 times. 4 into 28. 7. 5 into 28? Nope. 6 into 28? Nope. And I'm at 7, so I'm done. Okay, now I'm going to do 49. Okay, 1 and 49. Does 2 go into 49? No, because it's not even. Does 3 go into 49? Not evenly. How about 4? Nope. 5? Nope. 6? Nope. 7? Yes. 7 times 7. 8? Nope. 9? Nope. 10? Nope. What am I doing wrong? Anyone know? Hopefully, you know I'm going too far because I can stop at 7. Okay. All right, let's look at our factors now. Now I'm checking 3 lists. Okay? So, I know I have a 1 on each list. That's easy. I have a 2 here and a 2 here, but do I have a 2 here? Nope. Okay, I have a 7 here and I have a 7 here. And I have a 7 here. So my GCF is 7. Okay? And the quick check is take the 7. Can the 7 divide into 14? Yes. Can the 7 divide into 28? Yes. Can the 7 divide into 49? Yes. Okay, so double check that you definitely have a good factor, because sometimes we just write the wrong number accidentally, okay? Okay, So now you have solved them using your listing factors method, okay? What I want you to do now is copy down these 3 problems, and I want you to solve these 3 using factor trees, okay? So you're going to use prime factorization, okay? So okay, for our first one, we've got 20 and 45. For number 2, we have 32 and 90. And for number 3, we have 45, 75, and 120. Okay, so remember, you're going to be using your prime factorization method. Now, it's possible sometimes when we do prime factorization method, it takes a lot of space, because even just listing factors took up a lot of space, didn't it? So it's possible that your prime factorization method is going to take up a little bit more space. So if you need to have a piece of scrap paper so that you can keep your answers on the same page as your note examples, then that would be helpful, all right? So go ahead and stop the video and then come back after you've solved number 1 using prime factorization. So go ahead and stop, solve just number 1 using prime factorization. Okay, so hopefully you only did number 1, because I only wanted you to do number 1 because it does take a lot of room and it takes a lot of work to do this. And so I wanted to just go over it one by one with you, because this one's a little bit harder than just listing factors, okay? So for this one, the numbers were 20 and 45. So the first thing I'm going to do is start a factor tree for 20. And like I said, I always like to start with the lowest prime number that goes into the number. So the lowest prime number that goes into that number is 2. Okay, so 2 goes into 20 10 times. 2 is prime, so I stop. Then I come over here to the 10, and 2 is a factor of 10, so that's my lowest prime number. And it goes into the 10 5 times, and 5 is also a prime number, so I circle it too. And I know I can stop. So my prime factorization for 20 is 2 times 2 times 5. Okay, now let's do the 45. Okay, so 45. My lowest prime number that goes into 45 is not 2, because 2 doesn't go into 45. How about 3? Does 3 go into 45? It sure does. All right, so 3, that's a prime number, so I'm going to stop, goes into 45, 15. So 15 is a factor of 45. Okay, but 15 is not a prime number, so I have to keep going. Okay, so now I need a prime number that goes into 15. My lowest prime number is 2. Does 2 go into 15? Hopefully you said no. My next prime number is 3. Does 3 go into 15? Hopefully you said yes. And 3 goes into 15 5 times, so 5 is also a factor of 15, and 5 is prime, so I circle it. Okay, so my prime factorization for 45 is 2 times 2 times 3 times 5. Whew. Sorry. 3 times 3 times 5. Okay. So now I'm going to look at my lists and I am going to look for my common factors, my common prime factors. So 2, that doesn't work, okay? And it doesn't have to line up either. It could be in a different position, but nowhere in this list do I have a 2. And again, my next one for the 20 is a 2, but nowhere in my 45 do I have a 2. All right, my next one is a 5, and I do have a 5. So it's just 5 because I'm not multiplying it times anything, right? So my GCF equals 5. All right, so let's do number 2. Go ahead and pause my video and do number 2. All right, hopefully you just came back and you've already done number 2. And for space's sake, I'm just going to take this guy away and I'm going to put him on another piece of paper, okay? Because I'd rather you have neat notes than have a mess. All right, so prime factorization for 32 and 90 to find my GCF, okay? So 32. My lowest prime number that goes into 32 is 2. And 2 goes into 32 16 times. Now I'm done with my 2, so I circle it, and I'm going to the 16. Lowest prime number that goes into 16, or that is a factor of 16, is 2. And that goes into 16 8 times. So 8 is also a factor of 16. Okay, now I have an 8. 2 goes into 8, so that's a factor. Circle it because it's prime. And then 2 goes into 8 4 times. So 4 is not prime, so I've got to keep going. So 2 goes into 4 2 times, and those are both prime, so I'm done. Okay. Now I'm going to do 90. Okay, first one. 2 goes into 90. Yep, it does. How many times? 45. Hopefully that's what you came up with, right? Okay, now, does 2 go into 45? Nope. How about 3? Yep. It goes into 45 15 times, and the 3 is prime. Okay, and then 15, hopefully you remember this from 2 seconds ago, is 3 times 5, and both of those are prime. Okay, so now what I'm going to do is I'm going to list my prime factorization for both numbers. Okay, so I'm going to do it in another color. 32 is 2 times 2 times 2 times 2 times 2. And hopefully your brain is saying, oh, hey, I know there's a quicker way of writing that. And the quicker way of writing that is 2 to the 5th. But we don't need to do that today. I'm just reminding you that, remember, there's a quicker way to write 2 times 2 times 2 times 2. Blah, blah, blah. Okay. All right, 90. So I've got 2 times 3 times 3 times 5. Okay, now, once again, I'm looking for all the factors that are the same. So, well, I've got 2's, but I don't have any more 2's, do I? And I've got 3's, and I've got 5's, but I don't have any more of those, right? So my GCF for 32 and 90 is 2. All right. Okay, so now next page in your notebook. Number 3. We erased that before. Where did we put it? And I want to add it back in. 45, 75, and 120. Okay, so without going past about a half page, use about a half of your page to do this because you need some room for this one problem because you've got to do 3 factor trees, and factor trees take up a little bit of space, okay? I want you to do this one on your own tonight after you're done, okay? And then I want you to go ahead and work on your big ideas math activity. And when you work on that activity, hopefully you're going to be using the skills that we did in the notes today. And then tomorrow you're going to come back and we're going to solve this one together and do a little checkup and see how we're doing. All right, so we'll do a little checkup on this problem, see how you're doing. And then I've got some good word problems that we can practice with that I'd really like to do that tomorrow because you got to see word problems, right? Because most of your EOG and other types of tests are word problems. So we're going to work on those tomorrow, okay? So, bye.